Today's class, we will learn about the laws of motion. Now, there are three laws of motion. The first law says that a body will continue to be in a state of rest or of uniform motion in a straight line unless it is acted upon by some external force. That is known as the law of inertia. And the second law states that the rate of change of momentum is directly proportional to the external force applied on the body. And the third law, it states that for every action there is an equal and opposite reaction. So all these three laws you may have learned in class 9 in your secondary school. Now in the first law, this is known as the law of inertia. Now inertia is defined as the inability of a body to change its state by itself. So if a body is at rest, it will always continue to be at rest unless there is an external force applied on the body. And if a body is also in motion, then that body will always continue to be in motion unless some force is applied to stop that body. And if a body is moving in one particular direction, then again that body will continue to be in that particular direction until there is an external force applied on that body. So the first law of motion is known as the law of inertia. So you need to remember that inertia is the inability of a body to change its state by itself, either of rest, motion, or its direction. And the measurement of this inertia is given by the mass of the body. So if the body is heavy, then it is much more difficult to move the body or to stop the body or to change the direction of motion of the body. And if the body is light, that is, it's not heavy, okay, if it is light in weight, then it is easy for the body to be stopped or to make the body move in one direction or to change the direction of that of the motion of the particular light body. So mass will give us the measurement of the inertia of the body. Then we come to second law. Now this is a law which deals with momentum of a body. Now what is momentum? Momentum may be defined as the product of mass and the velocity of the body in motion. It is the total quantity of motion contained in a body, and it is denoted by letter P, small letter P, and this P is equal to mv. So this is known as momentum of a body. Now the momentum of the body depends upon the mass and the velocity. Now if the velocity is 0, that is, if the body is at rest, then there's no motion contained in the body. Hence the momentum of the body is equal to 0. So here if v is equal to 0, then obviously p is also equal to 0. So the momentum of the body is 0. And if the body is moving with finite velocity v, then the momentum of that body is given by mass into velocity. So this is your linear momentum. You have to remember this formula. If it's at rest, it is p is equal to 0. If it's moving with some velocity, then the momentum is equal to mass into velocity. Now the second law, it deals with this momentum. It states that if the rate of change of momentum is directly proportional to the external force applied on that body. So we'll take an example of a body first which is at rest. If it is at rest, the momentum is 0. So if the body is at rest, suppose we take this body of mass m. Let's say some ball of mass m, and this is at rest. And if the body is at rest, then the momentum is equal to 0. Now if we applied some force to this body, which is at rest, say we apply the force F, then this body will be in a state of motion. So, or in other words, this body will move. So the body changes its momentum from 0 to some finite value mv. So there is a change in momentum from 0 to mv. Now v is the velocity in which this body moves. So upon application of a force, there is a change in momentum, that is from the initial state p is equal to 0 to the final state. I'll denote this as p dash. P dash is equal to mv. So this change in momentum divided by the time taken to change the momentum from 0 to mv, okay, this is directly proportional to this force applied. So if the force you apply is large, then the rate of change of momentum, that is how fast the change in the momentum of the body, will also be large. Hence we can say that F is directly proportional to the rate of change of the momentum P. So this dt of P, this is the rate, can be read as the rate of change of momentum. How fast is the momentum of a body changing? Now this is when the force is not a constant force. Okay, if the force is constant, then we can write this one as change in momentum delta P divided by the time it takes to change its momentum from some initial value to some final value. For example, in this case, the momentum changes from P to P dash, and say delta T is the time taken for the body to change its momentum from 0 to mv. So the force will be directly, this force will be directly proportional to the change in momentum divided by the time interval, the time taken for the momentum to change. So this is the second law of motion, and from this formula we can derive the expression for the force. Now we can remove this proportionality sign. We will get F to be equal to constant K, which is equal to 1. Okay, in SI unit K is equal to 1, so we get K ddt of P. So in SI unit this is equal to 1, so we'll have F to be equal to d dt of P. Now P, we know that P is equal to mass into velocity, so here we'll write P to be equal to mv, and mass of a body doesn't change, it always remains constant. So here we can take mass outside of the differentiation, so we'll have mass here and then ddt of v. Now mass, and this is known as the rate of change of velocity. Now we have studied about the concept of displacement, velocity and acceleration, and acceleration is known as the rate of change of velocity. So here this rate of change of velocity, this is the acceleration of the body. So here the force will be equal to mass into acceleration. So this formula is familiar since class 9. So force is equal to mass into acceleration. Now since force is a vector quantity, okay, it has got a direction, so we will denote a vector quantity by adding an arrowhead, and acceleration also an arrowhead. So this is the mathematical expression for the second law, the Newton's second law. Force is equal to mass into acceleration, or force is directly proportional to the rate of change of the momentum. So now Now we come to the third law, which says that for every action there is an equal and opposite reaction. This is a very famous law. You always remember this law from your secondary school. Now we'll have to express this law in terms of a mathematical expression. So let us take, for example, if we have an object or a block of mass m which is under the influence of gravity. So if this block of mass m experiences a force which is downwards, which is the force of gravity, Fg, then according to the law there will be an equal and opposite reaction. So that reaction will be a force R, which is in the opposite direction. Okay, so here we have the action, which is the force acting downwards, and then we have the reaction, which is the force acting upwards. Or we can take another example. For example, we have two balls, one of mass m, one of mass m1, and another of mass m2. Then suppose this ball move in this direction. So the ball of mass m1 moves in this direction, and it collides with this ball of mass m2, which say it is at rest. So as this ball moves in this direction, it will collide with that of m2. So upon collision, this ball of mass m1 will exert a force on this ball of mass m2. So this ball will start moving. Okay, so the force exerted by this ball of mass m1 on m2, okay, can be given as F, force experienced by the ball of mass m2 due to the ball of mass m1, and it is in this direction. Now according to the third law, there will be an equal and opposite reaction. So if this ball experiences a force in this direction, then this ball also will experience a force in the opposite direction. So here this ball of mass m1 will experience a force in the opposite direction, which is equal and opposite to this force. So here the force experienced by the ball m1 is F1, 2. So the force experienced by the ball of mass m1 due to that of mass m2. So here you can see that F21 is in this direction, F12 is in this direction. So these two forces, they are equal and opposite. So according to the third law, we have F12 equal in magnitude to the force F21, but opposite in direction. So this is the third law of motion, that the force is equal in magnitude but opposite in direction to the applied force. So this can be taken as the action, and this can be taken as the reaction. Now we'll come to the concept of impulse. Now impulse can be defined as the product of the average force and the time in which the force acts upon a body, or it can also be defined as the total change of momentum of the body. For example, when a cricket ball is hit by a bat, the force of impact acts for a very small period of time, and that force is not usually constant, so it varies with time. Hence, in order to measure that force, we take the average force. and the average force in which the bat acts upon the ball, okay, is denoted by FAV, and impulse, okay, between the bat and the ball, okay, or the impact between the bat and the ball can be calculated as F into T. Now T is the time in which the ball hits the bat, or the bat hits the ball. So this FAV into T is known as impulse. Now this can also we can also derive or define impulse by using the second law of motion. Now according to the second law of motion, the force, say average force, is equal to the change in momentum divided by the time interval, and this change in momentum, say, is equal to P2 minus P1. P1 is the initial, so P2 is the final. So here P2 minus P1, and delta T is the time taken for the momentum to change from P1 to P2. And say, let's say this, I'll just leave that delta T as it is. So here we have FAV is equal to P2 minus P1 divided by delta T, and this delta T is very small. Okay, it's the time of impact. Okay, the time of impact between the bat and the ball. So if we multiply this one, FAV into delta T, we'll get P2 minus P1. So this is known as impulse, and it is equal to the change in momentum. Change in momentum of the body. Change in momentum of the body. So this is the concept of impulse. We need to remember the definition. Impulse may be defined as the total change of momentum of the body, or it is the product of the average force acting upon the body and the short period of time in which the force acts upon that body. So this concept will be applied to the law of conservation of momentum. Now the law of conservation of momentum, it states that if no external force acts on the body or on the system, then the total momentum of the system remains constant. So that is the law of conservation of momentum. Remember that word constant. Okay, if there's no external force acting upon a system, the momentum of the system remains constant. Constant, it means the same. So here we will consider two balls, M1 and M2. So we have here M1, then we have M2. Both these two balls, they move in one particular direction. So the momentum of this ball M1 is given as P1, and the momentum of this ball M2 is given as P2. Now the velocity of this M1 is greater than that of the velocity of this ball M2. So this ball M1 will collide with the ball M2, and upon collision, the velocity of this ball M1 will change, and the velocity of M2 will also change. So these two balls, upon collision, okay, M1 will move slower and M2 will move faster. So after the collision, M1 moves faster, and M1 moves slower, and M2, it moves faster. Okay, so there is a change of velocity, and if there's a change of velocity, there's a change in momentum. So here the momentum of m1 will be, say, p1 dash, and the momentum of m2 will be p2 dash. Remember, momentum is mass into velocity. So if the velocity changes, the momentum also changes. So here, before collision, what is the momentum? Total momentum of this system, m1, m2, p1 plus p2. So this is the total momentum of the system of the balls m1, m2. So this is before collision. After collision, it will be p1 dash plus p2 dash. So here, if there is no external force acting upon this system, okay, if we have m1 to be moving with the initial velocity, initial momentum p1, m2 moving with the initial momentum p2, and upon collision, okay, there's no external force here. Upon collision and after collision, it moves with momentum p1 dash and moves with momentum p2 dash. And according to the law of conservation of momentum, the total momentum p1 plus p2 will be equal to the total momentum p1 dash plus p2 dash. So this is the law of conservation of momentum, and if we have to prove this one, we'll have to prove that p1 plus p2 is equal to p1 dash plus p2 dash. Now to prove this one, we'll have to use the laws of motion and the concept of impulse. So the third law of motion and the concept of impulse. Now, as I've told you before, if this ball collides with this one, then this ball will exert a force on this ball m2. So the force exerted by this m1 and m2 is given as F21. So this is read as force exerted on m2 due to m1. And another force is the force of reaction, and that is denoted by F12. This is read as force exerted on m1 due to the ball m2. So this is the reaction force, and this is the action force. So reaction and action. Now, according to this concept of impulse, what we have is that the force F12, okay, so or the impulse experienced by the ball of mass m1 is given as F12 delta t, and this is equal to the change in momentum. Momentum is p1 dash of the mass m1. So the change in momentum will be p1 dash minus p1. So this is the impulse. Now this delta t is the short period of time in which the force acts on this ball of mass m2. So this is the impulse experienced by m1, and the impulse experienced by m2 will be F21 delta t. This is equal to p2 dash minus p1 or p2. Now, according to the third law, this F12, this is equal in magnitude to F21, but opposite in direction. So F12 is equal to minus F21. So if we put this F12 here, we will get minus F21. Now if we bring this minus this side, then this will become minus and this will become plus. Or in other words, we'll have P1 minus P1 dash. Or we'll have this P1 minus P1 dash. P1 minus P1 dash. So if we compare the two equations, they are equal. Hence we have P1 minus P1 dash, this is equal to P2 dash minus P2. And if we bring this minus P2 this side, it will become plus, so we have plus P2. And if we bring this one this side, it will become plus P1 dash, so we have P1 dash plus P2 dash. So this is the proof of the conservation of momentum. So we have used the concept of impulse and the Newton's third law of motion. The total momentum before collision is equal to the total momentum after collision. Okay, so this is known as the law of conservation of momentum.